Okay, well, thank you, Jan. Welcome everybody to the Murray Amateur Radio Club's Thursday Zoom meeting. We have a good quorum tonight, so I hope everybody enjoys their time here with us. Tonight, we are going to have a presentation by Jan. And so before we go there, I want to turn the time over to Ragnar. I think he has something for us.
Oh yeah, that's right. You requested a joke. Well, I was thinking about that, and I just well, there's a joke. I've got a good joke about a dog, but I was thinking about this instead. I belong to a few groups on Facebook, and UFTA is one of them. UFTA is a general phrase they use for something goes wrong. Like instead of swearing, people use UFTA a lot. So now it applies to almost anything. But I've been going through this and checking a lot of interesting things going on. And things have changed a lot in Norway since I was young. First of all, I grew up in a community where you had white fish with white potatoes and boiled potatoes. And then you had exciting things like white sauce on top of your green peas, for example, for color. So the diets have changed since the late 60s and early 70s. Everyone in Norway came up with this idea of having tacos. And if you can believe this society where fish is the basis of everything, and anything spicy is like a little bit of pepper, and they have tacos on Friday night. It's a big national thing going on now. And can you imagine all these Norwegians, and the big thing for Friday night is tacos.
They're not lutefisk tacos, are they?
They're not lutefisk tacos.
Oh, thank goodness. Thank goodness.
Yeah. And so I just thought that was the real joke, that I never thought about this. But anyway, going back to the real joke. One day, my dog ate all my little Scrabble tiles and all the letters. And anyway,
I can see where this is going.
Anyway, from that point on, for about a week, my dog just kept leaving all these messages around the house. I just thought you should know. I'm done.
Thanks, Ragnar.
You're done all right, Ragnar. Thanks.
Okay, Jan, it's all yours.
All right, let me get my screen sharing up. And I believe this is the screen I want. Okay, can everybody see my fancy schmancy screen here?
Affirmative.
All right, so we're going to talk about radio linking via the internet. And to start us off, I have a little video. So I'm going to play this video. And for those of you who are not familiar with the IT crowd, just play along. Just play along. If you are familiar with it, you will know this bit. It sounds like Neil knows this bit.
Oh, yeah.
Can everybody hear that audio okay?
Yes.
Okay.
Yep.
What is it?
This, Jen, is the internet.
What?
That's right.
This is the internet. The whole internet.
Yep. I asked for a loan of it so that you could use it in your speech.
It's so small.
That's one of the surprising things about it.
Hang on. It doesn't have any wires or anything.
It's wireless.
Oh, yes, everything's wireless nowadays, isn't it? So I can really use it in my speech. What if someone needs it?
Oh, no. People will still be able to go online and everything. It'll still work.
Oh, good.
I tell you, you present this to the shareholders and you will get quite a response.
Can I touch it? Ooh. It's so light.
Of course it is, Jen. The internet doesn't weigh anything.
No, of course it doesn't.
Hey! What is Jen doing with the internet?
Ma said I could use it for my speech.
Are you insane? What if she drops it?
I won't drop it. I'll look after it.
No, Jen. No, this needs to go straight back to Big Ben.
Big Ben.
Yeah, it goes on top of Big Ben. That's where you get the best reception.
All right, I promise I won't let anything happen to it.
No, Jen, I'm sorry, but the elders of the internet would never stand for it.
No, Roy, I spoke to the elders of the internet not 1 hour ago. I told them about Jen winning Employee of the Month, and they were so impressed that they wanted to do whatever they could to help.
Wait a minute. The elders of the internet. The elders of the internet know who I am. You've got to let me have it.
No, Jen, I'm sorry, it's just too risky.
Oh, please, Roy.
Oh, well, Moss, has it been completely demagnetized?
By Stephen Hawking himself. Who sent his congratulations, by the way.
Well, if it's okay with the hawk.
So, can I have it?
You can.
Oh, don't forget your speech.
Oh, thank you.
Slowly.
Okay. Whoop, sorry. Okay, for real, what is the internet? So the internet is, so let's talk about an internet first, okay? An internet is an interconnection of multiple networks using a reliable network protocol, typically TCP/IP these days, and using some kind of routing or forwarding mechanism for directing traffic. The idea being that the network is robust, in that if a particular link goes down, things will route around that down link and find another way to get to their destination. It facilitates communications between networks and network devices. Now, when we talk about the internet, notice the capital I, that is the global internet that we all know and love and use daily, and in fact are using right now. So you can have an internet that is not the internet, but when we always talk about the internet, I'll always use a capital I for that, just so that you know what I'm talking about. So it handles many services, including World Wide Web, email, chat, video conferencing, file sharing, file transfer, telemetry, video, other data. Let's talk about other data. So the underlying protocols of the internet ensure the delivery of streams of data, okay? They don't care what's in those streams. So you can take any data that you want and shove it into a TCP connection, and it is guaranteed to either come out the other end in the same order you put it in, or to not get there at all. And you will know that it didn't get there. It's guaranteed delivery or failure that is known. So what we can do with those streams of data, we can encode audio and push it through those streams. And that audio can come and go to a radio, which is what we know and love, right? So we're going to talk about radio linking. So we have our repeater networks, and we've talked about things like the Intermountain Intertie. We had a class on that at one point back when we were meeting in person. Intermountain Intertie has radio repeaters from all the way up in West Yellowstone, Montana, all the way down to Las Vegas, and they're all connected using RF links. So if you key up a radio or repeater on that link, on that system, all those repeaters on the entire system will key up, and anything that you transmit will be retransmitted out all of those repeaters across the entire system. So here in Utah, we have the Intermountain Intertie, we have the Sinbad system, and there's at least one other repeater network here. Plus, there are lots of setups where they have, 2 or 3 repeaters connected together, kind of like what Dan was talking about with our repeater that we're putting on the tower by the animal control. We will also have a repeater on 440 that will be linked to that. So anything that goes into that 220 repeater will also come out on the 440 side and vice versa. Is that correct, Dan? Correct me if I'm wrong.
That is correct.
Okay, so that was the plan. So another system that I'm familiar with is called Carla, which is a system in California that basically spans pretty much everything from Lake Tahoe down to San Diego. And, it's a fully linked system as well. It does actually depend on some internet-based links as well as RF links, but we'll talk about that in a minute. So these individual repeaters, they use RF links pointed at each other to build an RF network of repeaters. They're usually limited in scope. For example, the intertie goes from Idaho Falls or even up as far as West Yellowstone, Montana, all the way down to Las Vegas. Carla covers most of California, all the way down to San Diego. Why not replace one or more of those RF links with a data stream over the internet? So we're going to talk about internet linking. There's multiple ways to link these repeaters together. IRLP, the Internet Radio Linking Protocol, EchoLink. There's a system called WiresX that is a Yaesu product. We're actually not going to talk about that because I don't have any Yaesu gear and I'm not familiar enough with it. There's also things like D-Star, DMR, and Yaesu System Fusion that are digital modes that also have the ability to interlink the repeaters over the internet. And we talked about DMR before. We haven't really talked about D-Star or System Fusion before, but we're going to avoid talking about them in this presentation because we're talking primarily about analog type systems. So we're going to talk about IRLP. We're going to talk about EchoLink. So let's start with IRLP. So Internet Radio Linking Project. So just like the name says, it linked radios together over the internet. Their tagline is putting the radio back in amateur radio, right? So the system was originally developed by Dave Cameron, VE7 Ltd. If you realize or recognize that call sign that starts with a V, VE, he's Canadian. So he actually lives in British Columbia. His original system was deployed in 1997. He had 3 loads, one in Vancouver, British Columbia, one in Vernon, British Columbia, and I'm not sure why that decided to split the word Vernon right there, but I'll fix that later, and one in St. John, New Brunswick, which is not anywhere near British Columbia. So it was originally written on a Windows-based system. It was not super reliable. It was not super stable. And in fact, it kind of sucked a little bit, but it proved the concept. And so Dave rewrote some of the software and worked it out to where he could run it on the Linux operating system in 1998. And so since then, it has been deployed across Canada, across the United States, and all over the world. So let's talk a little bit about how IRLP works. So if you want to have an IRLP node, you've got to have a computer. It doesn't have to be a high-end computer. The spec calls for at least a Pentium 3. Now, I don't know if you guys are real familiar with computer types, but Pentium 3 was the new hotness back in 95, I think, 96, somewhere around there. Probably 96, 97, right? So Pentium 3 at 500 megahertz. My phone probably has more power than that right now. The phone, sitting right here next to me is probably faster than a Pentium 3 at 500 megahertz. 512 megabytes of RAM, not gigabytes, megabytes of RAM. So like a ridiculously low amount of RAM requirement, and a 5 gigabyte disk. Now, back in, 97, 98, 99, that was a pretty reasonable system to have. That was not a small system. You had to have a pretty good computer back then. But nowadays, when you think about that, it's like, I can probably buy that in a Raspberry Pi format for $45, right?
Yep.
The key factors are the system had to have a legacy parallel port or some equivalent mechanism. So your Raspberry Pi doesn't have a parallel port on it, but it does have those GPIO pins on it, and you can tie into those. So it basically does the same thing as the parallel port. Had to have a sound card because you needed to have some way to get audio in and out of the computer. And it had to have an Ethernet connection with some kind of internet service. A lot of these guys originally were running this stuff on a dial-up network, believe it or not, because you didn't need a lot of bandwidth to run one of these. You also have to have a link radio or a repeater. So you have to have some way to tie into the RF side, right? So typically, if you had a repeater and you were installing your node at the repeater site, you would tie it directly into one of the audio channels on the repeater. Otherwise, what you would do is have a separate link radio that was on the repeater's frequency, and it acted just like another repeater user. And you could have that anywhere in the range of the repeater. One of the key factors about IRLP, or one of the requirements, is that the radio that you're connecting to has to have carrier operated squelch. And what that means is that the radio doesn't make any noise unless a carrier is detected. And it actually tells you, hey, I'm detecting a carrier. So you can detect that in software on the computer side and say, oh, okay, somebody has keyed up the radio and I should actually start listening now. Also, when using it on a repeater type system, you need to have it configured to have no hang time or courtesy tones. If you guys aren't familiar with those concepts, hang time is where when you stop transmitting and you unkey your radio, the repeater keeps listening for a few seconds. That's called hang time. Keeps listening and retransmitting for a few seconds. And the courtesy tones are when you unkey, the repeater plays some kind of musical tone to allow people to know that, hey, you stopped transmitting. In our check-in net that we did this evening, Sammy's repeater is connected or is configured with courtesy tones. So if you were listening, you would notice that whenever someone would unkey, you'd get this kind of boodly deep sound, and that would indicate, hey, whoever that was unkeyed. You don't want those tones going across the IRLP network to the other end. Okay. The other item that you need, other hardware item that you need, is an IRLP interface board. And this is a physical device that connects to your computer via the audio and parallel port or other ports, depending on how you do it, and connects to the radio via the microphone, speaker, PTT connections, or through a data connection if your radio has one of those. Pretty straightforward, pretty simple to set it up. How does it work? Well, it's pretty cool. The radio receives a signal just like a normal repeater would. The IRLP board observes that the carrier operated squelch is happening. So the radio has turned that on. So the IRLP board notices that and it advises the software, hey, this is happening. The audio that the repeater receives is sent over to the computer through the sound card. The computer gets the audio and processes it using a software package called Speak Freely, which is free software. That software takes the audio, encodes it digitally, chops it up into packets or segments or chunks or however you want to visualize that, sends those over the network. Those packets are sent over the network to another node, and the receiving node hands the incoming packets to that Speak Freely software, which decodes them, converts them back into audio, and the audio is sent out through the sound card. And the IRLP board coordinates the activation of the radio's PTT with that outbound audio, and the remote system's radio sends that audio out over the air. So pretty simple, pretty straightforward. The IRLP board also includes a DTMF decoder, so it can receive instructions from the radio operator, like which node to connect to, when to drop the connection, and that kind of stuff. So this is a diagram that shows a typical IRLP node. And so you can see here your local repeater. Can you guys see my mouse moving around?
Yes.
Okay, so your local repeater is here, and somewhere distant from that, like at your house, is a low power link radio with a nice directional antenna pointed at the repeater on those frequencies that are able to talk to the repeater. That radio has its PTT connected to the IRLP board. The carrier operated squelch signal from the radio goes into the IRLP board. The speaker audio from the radio goes to the sound card in the computer and also is split to go into the IRLP board so the IRLP board can pick up the DTMF if there is any. And the sound card speaker port or output port is connected to the microphone in port or sound in line in port on the radio itself, right? So the IRLP board has some logic on it that handles controlling this PTT, handles receiving this carrier operated squelch signal, handles decoding the DTMF. It communicates to the system with this serial port or this parallel port connection. It has 3 switches on it that you can set. I have no idea what those switches do or what they're there for. They have separate purposes that I haven't looked into. We could probably dig that information out of the IRLP site. The parallel port connects the PTT signal, the carrier operated squelch from the receiver, and handles sending DTMF digits to the IRLP software. So running on the PC, you have the IRLP software running, and it receives or handles these data inputs and outputs through the parallel port. It handles the sound audio through the audio card, the sound card, and it handles the network communications through the machine's network card. And so it says you need 36 kilobits per second of sustained bandwidth, or 6 for AED PCM type audio, or 16 kilobits per second for GSM. So that's not a lot of bandwidth. It doesn't take very much bandwidth at all. So that's a typical simplex node. Well, let's see. How did I switch to that? I was on this one, which was the typical repeater node. This is the one that I thought I was showing you. Basically, all of what I just said is the same. The only difference being this low power link radio that goes to the repeater. On a typical simplex node, the simplex radio handles the communication directly. So when you're out here with your handy talkie or your mobile radio, you're communicating directly to this simplex node. There's no repeater involved. Other than that, everything else works exactly the same. So there's a public database of known nodes. Each node is identified by a 4-digit number. The nodes can be connected directly, node to node, or the nodes can connect to a system called a reflector. And reflectors, they accept connections from multiple nodes and pass receive packets back to all the other connected nodes. So if you think about that, think of it kind of like a party line, where if you have your IRLP node and you connect up to one of these reflectors, and there's a guy in New Zealand who's connected to that reflector, and there's a guy in Boston that's connected to that reflector, and there's a guy in Alaska that's connected to that reflector, then anything you say can be heard in all of those locations simultaneously. So think of it as a well, by the term reflector, you can kind of get the idea. It's like a mirror. So anything that you send to it gets resent out to everybody else, and anything that they send gets resent out to everybody else, including you.
There are 2,406 nodes in the U.S., and it's a worldwide thing.
It is a worldwide thing. So one thing about reflectors is they're not directly connected to a radio. They facilitate wide area connections between multiple nodes. So they're kind of a special class of node, and so they don't actually have a radio directly connected to them. Let's see. I've got a bunch of things in the chat here. what do we got going on? Chris was complaining that he couldn't see anything, hear anything. Well, I guess Chris is out of luck. Sorry, Chris. Did he leave? He did not leave. So I don't know if he's been able to resolve his problem or not. Okay. So that's basically how it works. So how does it really work, right? So I have my radio. I tune my radio to a repeater frequency that has an IRLP node associated with it. I key up my radio and I say something like, this is KD7ZWV. I'm going to use IRLP to connect to node 2525. I punch in the DTMF commands to tell the IRLP node to connect, and the node makes the connection to the other node, and I can key up and talk. Whatever I say is sent to the faraway node and transmitted out on the radio there. Some other operator there here's my signal. They respond. We have a QSO. When we're all done, I key up and say, thanks for the QSO, and I'll see you later. And I key in 73 on my DTMF pad, and the node drops the connection. Very simple, very straightforward. Now, I had planned to do a live demo here, but I did not bring my radio with me when I set this up. So I'm not going to do a live demo, but what I am going to do is show the website and talk about some of the things that it does. So let me stop sharing this. And let me find my window here. Where did you go, Zoom? And I'm going to share this screen. Okay, so everybody should be able to see my browser here. And I'm actually on this status.irlp.net. And on this one, I've actually done a search for nodes here in Utah, close to us, right? And so you can see it came up with 1, 2, 3, 4, 5 nodes that are relatively close to us. I actually talked to K7MLA and got permission to demo using his node, but then I didn't set my radio up for it, so I'm not going to be able to do that. His node is at Butterfield Peak. So if you look on our standard load, I think it's listed as Butterfield. I'm not positive. I'll have to look that up. But it's 147.14. And you'll notice that some of these have 0 for the frequency. That means that these nodes are not actually connected to a radio that people can use. They're just nodes that are known to the system, but you wouldn't actually try to connect to this and try to talk to somebody because it's not actually connected to a radio right now. But if we go look at node 3215, which is that Butterfield node, you will see, I don't know if that's going to show up because it showed up in a pop-up. You guys probably can't see it. Let me see if I can bring it up in a separate tab here. And it says it blocked it. That's very unhelpful. Well, I'm not going to be able to show you that. So basically what this is showing me is that the node is up, that it's idle, and that it has been idle for 4 days, 18 hours, 55 minutes, and 38 seconds. It says when it was last heard from. It includes things like the latitude and longitude of the node, the name of the owner or sponsor of the node. It has a link to be able to ask the operator a question by email, and that kind of thing. So we'll continue on with some of the other stuff that you can do here. So this is a page that shows the reflector usage. And so you can see the different reflectors. This is reflector 9050. There are 37 nodes connected. Let me refresh this page. There are 36 nodes connected to 9050 right now. And the reflectors have multiple channels. So you can see this one has channel 0, and there's a whole bunch of stuff connected to channel 0. And then it also has channel 5, and there's only 2 nodes connected to channel 5. Each one of these nodes has its node ID number. it has the call sign of the node and the location of the node. So you can see that this guy, there are people connected from Portland, San Jose, um, Port Henry, there's Charleston, Reno, lots, Juneau, Alaska, lots of different places are connected. So if I was to connect to this reflector, anything that I send out is going to go to all of these other nodes and be heard in that area. Auckland, New Zealand, um, Plattsburgh, uh, Englewood, California, um, all over the place, right? So that's reflector 9050. There's also reflector 9220 that has 27 nodes connected to it. There's reflector 9100, which has 22 nodes on it, and multiple other reflectors that you can see on this list, right? So let's look at some of the other options on here. We'll go to this summary. This basically shows you, the summary page shows you the active nodes. There are 1,235 nodes on the network actively connected to something else. There are 910 idle nodes, 325 in calls, 46 are down, and 18 are offline. These are the reflectors in the system. So you have like the Vancouver reflector, we have the East Coast reflector, we have the Alaska reflector, we have the Western area annex, reflector annex. There's also the Western area reflector. The annex would be like a auxiliary, an additional Western reflector. This is the main Western reflector. That's that 9250 that we were just looking at a minute ago. And it shows what the activity is on those nodes. So let's go ahead and look at connected nodes. And here you can see all the nodes that are currently connected to the system. And you'll observe that some of these say idle. Some of them say like linked to 9300. So this one is connected to that 9300 reflector. Let's see if we can find one here's one here. This guy in Camrose, Camrose is linked to node 0082. So if we go back and we find, I don't know where the zeros are. I don't see any that start with 0. Maybe they're at the end of the list. You can see there's a lot of nodes out there. I don't see zeros or 82. Oh, well. Let's find a different guy here that we can pick on. Okay, here's one. This guy in Las Vegas, KE4CNU, node 7158, is currently linked to 8025. So if we go down and find 8025, we should see that he is right here, AI4LL in Callaway, Virginia, is linked to 7158. So you can see it's a point-to-point link between those two nodes. So they're not talking on a reflector, they're just talking directly to each other. Going back to that page that I had up in the first place, you'll see that we actually have a few different nodes around here. We used to have another node that was always online and connected to the Western area reflector, but it's been offline for 280 days. I'm not sure what happened to it. Unfortunately, I haven't had a chance to track down the owner of that and find out what's going on with it. But this node at Butterfield Peak, let's go ahead and pull up. Let me pull up the Utah VHF Society. If you guys aren't familiar with this page, this is the Utah VHF Society. They are the frequency coordinator in the state of Utah. So they maintain the repeater list of all of the active repeaters that are in Utah and some surrounding areas. So if we look, let's go back and look at this real quick and see This was 3215 was that node. So if we look at this list and we search for 3215, you'll see it right here. And it says that this node is attached to the repeater at Butterfield Peak, 147 to 14, positive offset with tone 127.3. That's an open system, and it's linked to 147 240. And it has this, any of these that you see with the I and a number, those are on IRLP. And we're going to talk about the E's in a minute. But yeah, basically all of these guys with the I are on IRLP. So anything that you find in here that has an I on it, if I was able to show you on my radio right now, I'd actually be able to connect into, say, this node in Castledale by punching in its IRLP number and connecting to it over IRLP. And then I could talk to somebody in Castledale or Price area through IRLP. So one thing to notice on, let me see, that's the page I can't show you. Let me see if I can't share this other page here. Hang on. I want to share this guy. All right, so this is the detail page for the node. And one of the things that you can do when you're looking at this is scroll down and you'll see if it's got public access procedures, it'll actually tell you how to do it. And so one of the things that Marty has said is if you want to send or do this, prefix all your commands with a DTMF-D. The IRLP board actually can't hear the code D, but that tells his repeater controller to send the rest of your DTMF to the IRLP system. So if I wanted to dial up that node, which was, what was it? It was 3270 is the one in Castledale, right? If I wanted to dial that guy up, let me get that page back. I would key up, I'd hit D on my DTMF pad on my radio, and then 3270, and then the node would make the connection. And when I'm all done, I would hit D73 to close the connection down again. All right, let me close that back up. We'll go back to the presentation. Okay, so that's IRLP in a nutshell. We're going to move on now. We'll talk a little bit about EchoLink. So IRLP is great, fabulous. However, of course, in the world of the internet and modern times, if one system is good, if one protocol is good, then two protocols must be better, right? So there's another system called EchoLink. This was developed by a guy named Jonathan Taylor, K1RFD, around. Go ahead.
Just so everybody knows, we use an EchoLink connection when we do the Skywarn 24-hour event up at the Weather Service. So there is a IRLP controlled radio with the computer there as we do that. So we use it at least once a year at the Weather Service.
Okay, so EchoLink, developed in 2002, runs on Windows. There's a Windows application for it. There are compatible versions for Android, iOS, which is what your iPhone or iPad use, Mac OS, and Linux. You can also run it on Mac OS and Linux using Wine, which is, if you're not familiar with Wine, Wine stands for Wine is not an emulator. But it actually basically lets you run Windows programs on Mac OS and Linux if those programs are written correctly. So it doesn't always work well for games, but it works great for EchoLink. One interesting thing about EchoLink, no radio is required. Okay, EchoLink is for linking hams, not radios. Now, you can tie the EchoLink system into a repeater in a similar fashion that we do on IRLP, but you can also run the application directly on your computer, on your phone, and connect directly into EchoLink and make connections with other hams without even having a radio. And we'll do a quick demo of that too in a minute. So because of that capability, in order to activate an EchoLink account, you have to validate your amateur radio license. And we'll talk a little bit more about that later. You can run EchoLink in either user mode or SysOp mode or SysOp. I don't know how people pronounce that. I used to do bulletin board systems way back in the day, and we always called it SysOp, but some people call it SysOp, system operator. So call it what you want. User mode is for a user directly connected to the internet, no radio required. You run it directly on your computer or your phone or whatever. SysOp mode is similar to the IRLP model, where the node connects to a repeater or a simplex radio and handles the RF side going through the radio, right? So hardware requirements in user mode, all you need is a PC with a sound card, mic and speakers or headphones, and a connection to the internet, or a cell phone with the ability to run an app on it, like an Android phone or an iPhone or something like that, or a tablet or something like that that has a microphone and speakers or the ability to hook up a headset and a connection to the internet. In SysOp mode, you need some kind of an interface board to allow your PC to key up the radio and a sound card connected to the radio's mic and headphone ports. Does that sound familiar? It should. We talked about having exactly that for IRLP. In fact, in IRLP land, you have to have a specific IRLP device that you purchase from IRLP.org. EchoLink says, hey, build your own, use a commercial solution like a rig blaster, use whatever you want to connect your radio up to your PC. As long as you can do that, you can do that. So how does it work? First thing, you have to have your license validated before you can use EchoLink. So when you go to install EchoLink, the first thing you do is you start it up and it says, hey, log in. And you put in your call sign and you give it a password and it says, great, thanks. Now go here and validate yourself. And in order to validate yourself, you have to send them an official copy of your amateur license. Now, obviously, you don't want to send them your only paper copy of your license if you happen to have a paper copy, but they are adamant that it be an official copy, not a reference copy. So, for example, I can go to the FCC and download a copy of Dan's license if I want to verify that Dan is who he says, that he has a license. But Dan shakes his head no. But that is a reference copy, not an official copy. I can only download an official copy for myself. How do you know the difference? I'll show you in a second. We'll get to that in a minute. In order to validate yourself, you have to go to this secure.echolink.org/validation page. This will actually tell you what to do and walk you through it. It's really not that hard to do. This will actually walk you through getting an official copy of your license and tell you how to upload it and all of that. Other countries, non-US countries, they have different mechanisms for obtaining an official copy. EchoLink will actually tell you how to do that. There are documents online that tell you how to do that for different countries. Once you have that done and your account is active, then all you have to do is log into the application and you'll be able to see a list of stations, or you can search for one, and you can connect to a station or a repeater or a conference. So these are some interesting terms: station, repeater, or conference. A station is a user, right? So if I'm connected, I'm a station. If my station has -R on the end of it, then it's connected to a physical repeater. If my station has -L on it, it's connected to a simplex radio. Remember, we talked about how IRLP could be connected to a repeater or attached to a simplex radio. Same thing with EchoLink. They use this syntax, this -R and -L, to indicate to the users if they're connecting to a repeater or to a simplex frequency. Why is that important? Why does it matter if it's a repeater or a simplex frequency? Anybody have any ideas? I hear a lot of silence. The main idea is if I'm connected to a simplex frequency and the EchoLink or IRLP system is talking, I can't talk. So I can't send it commands saying drop the connection unless it's not transmitting. It can only receive me when it's not transmitting. So that's why it's important to know the difference. A conference is similar to a reflector in IRLP land, right? So it's a named collection of connected stations. We're going to do a little demo in a minute and show you how that works. But basically, you double click on the station to connect to it, and you talk on your PC's mic and speakers or a headset. And to end the call, you click the disconnect button. If your EchoLink connection is through a repeater or simplex, you key up, announce you're going to be using EchoLink, send the node number you want to connect to via your DTMF pad, prefixed with the character C to indicate connecting, have your QSO, and then to drop the connection, you send a pound symbol from your DTMF pad to disconnect. Pretty straightforward stuff. All right. So again, I have a spot for a live demo, and I'm actually going to show you. Let's see. We've got some more chats happening here. What do we got? Chris says the audio is fuzzy. I'm sorry about that, Chris. And the slides are out of focus. Wow. That's odd. Okay. Well, sorry, Chris. I guess you'll have to watch the recording later. Anyway, let me pull this up and we'll see if we can't do an actual demo here. So I'm going to show you this software. Let me do this a little different. Let me redo this with, share sound is on. Okay. So this is the Macintosh version of the EchoLink software. It's called EchoHam. There used to be one called EchoMac, but Apple said, hey, you can't name anything with Mac in the name. That's ours. So don't do that. And so the guys who wrote this said, okay, we'll call it EchoHam instead. And they said, hey, that's great. No problem. This does not cost any money. You can download this from the Apple App Store. If you have a Macintosh, you can download it from the Apple App Store for free. If you're on Windows, you can download the Windows EchoLink application also for free. And if you're on Linux, there are corresponding Linux versions of that software as well. So I'm actually connected at this point. You can see this shows that I'm connected to a server. One of the interesting things about EchoLink is when I connect to the server, I'm basically sending some information about myself to the server and getting back information about other stations. When I talk to another station, I will actually connect directly to that other station and vice versa. So the server is not involved. There's no server involved in that communication. For that to work, I have to have a public IP address. And I also have to have it set up so that connections or ports that I open on my machine can actually be connected to from outside. Now, the software tries to use a protocol called UPnP to set that up. I was not able to get that to work with my router, so I had to actually set specific port forwards on my router to be able to do this inbound connection. I could do an outbound connection, no problem, but the inbound connection, I could not do that without that. So let's go ahead and look at what we got here. You got a list of countries, right? So let's see if we go down this list, we should find US. And look, here's a list of stations in the United States that are all on EchoLink. And these guys are all on right now. So if you look at these, most of them have the little -R on the end, right? So K3CSF-R is in Pittsburgh, Pennsylvania. If we want to connect to that, we just click on that guy and we're connected. And I have a little PTT button. I'm not actually going to talk on that because I don't know anybody in Pennsylvania. I'm going to go ahead and disconnect. I'm actually going to show you how that works, though. So one of the things that it also has is this list of conference servers, and you can see there's a bunch of different conferences up here. One of the ones that is on here is called Echo Test. So what this one does is anything I say to it will come back to me. So I'm going to go ahead.
Welcome to the EchoLink test server. This server records your transmissions and plays them back to help you adjust your transmitted and received audio. Please feel free to connect as often as you like.
Okay, did everybody hear that?
Yep.
Okay, so I'm going to go ahead and open my PTT and say something here. KD7ZWV testing my connection to the Echo Test server. KD7ZWV testing my connection to the Echo Test server. And there you can see how it works. So pretty straightforward. Basically, if I connect it to one of these other conferences, here's one in France, here's one in Handy Hams. I don't if you guys aren't familiar with Handy Hams, there's a whole subgenre of amateur radio operators who are handicapped. They might be blind, they might be deaf, they might be paraplegic or quadriplegic, but they can still operate a radio. And they have a whole group called Handy Hams. So they actually have a conference on here on EchoLink where they can talk to each other. So that's kind of cool. Go ahead and look down here and we'll see somewhere in here was a, where was it? It should still be here. There's Skynet, right? So we remember Dan talked about Skynet. There's actually a Skynet conference. I thought there was a Salt Lake one, but I'm not seeing it for some reason.
There was just a Price, Utah one.
Is there a Price, Utah one?
Yeah, it's down. It's right next to the two up from the blue one.
Let's try searching for it.
Sinbad.
Yeah, it's a Sinbad, Price, Utah.
Do Sinbad.
I've observed that on the Mac version of this software, the searching doesn't work real great on the conferences. All right, so Sinbad was one. There it is right there, right? So Sinbad's apparently their link system is tied into EchoLink as well. So we could connect up to that if we wanted to. We'll go ahead and disconnect from the Echo server. But basically, so I can search like KD7, and you see how this narrows down. There's actually my node right there, KD7ZWV. I could also pick on somebody like right here. You don't
see that.
You don't see the drop down?
No.
Oh, so there's a little drop as I start typing. There's a little drop down that appears. Let me go ahead and see if I can't break the search down like that. Okay, so you can see. Here's mine right here, KD7ZWV. There's a couple of others that are user connections. Baker City, there's one in Provo. Somebody in Provo is on. Then these -Ls are those simplex type links, and the -Rs are the repeater type links that we talked about. So really simple, easy to use. The Android version is also super simple and easy to use. I haven't actually used the iPhone version myself, but I have no reason to believe it would be any more difficult. It's just super easy to work with it. You also have the ability, once you're connected, even if you're not talking in audio, you can type and have a chat conversation over EchoLink. Obviously, you can't do that with a repeater or a simplex link, but you could do it with a direct user connection. So pretty simple, pretty cool stuff. I'm going to go ahead and disconnect here. and shut this guy down. And we'll go back to, let's see. Somebody says, iPhone EchoLink works very well, very simple. Chris got his internet working better, so that's good. Yeah, so let's go back into the presentation. All right. So there's also, if you remember back, let's go back to, actually, let me stop this for a second and go back to this one. Which one was it? Where did it go? I only have about 8 million windows open, so it takes me a minute to figure out which one I want. I bring my this one right here. Okay, so this was our Utah VHF Society repeater list. You notice some of these guys have both an I number and an E number. They're on both IRLP and on EchoLink, right? So that's kind of cool. So let's talk about that a little bit. There's actually a system called EchoIRLP. So if you have an IRLP node set up, you can run this software on that node, and it will allow your IRLP node to also be an EchoLink node or station. So IRLP is the primary node. So connecting to IRLP nodes is done in the standard way. EchoLink's an auxiliary node mode. So you typically have to prefix with a special character that's determined by the owner of the system. It's usually the DTMFC character. So if you look on your radio that has a keypad on it, you will see that it has the number pad and then it has A, B, C, and D. Those are actually DTMF characters that are part of the DTMF keypad. And C is typically the one that you use to tell EchoIRLP node that you want to do an EchoLink connection as opposed to an IRLP connection. Wires X, again, I'm not going to talk too much about it because I don't really know anything about it. It's Yaesu specific, and there's a link to the website that has more information about that. When I post this up on the website tonight, I'll make sure that these links are all available for clicking, easy clicking. And then, of course, there's the digital modes, DMR, D-Star, System Fusion. They all provide some kind of node linking mechanism. We'll talk about those another time. We've already talked about DMR before. We'll try to cover D-Star and System Fusion another time, and maybe we'll have just a general digital modes class as well. Let's talk about etiquette of working on one of these IRLP type systems or EchoLink type systems. First rule, if the node wasn't connected when you started, don't leave it connected when you're done. So if you get on a repeater that's on IRLP or you connect to an EchoLink station, if you made the connection, you should tear that connection down when you're finished or hand it off to somebody else who's on the repeater right then and you know that they want to continue using it. You can hand it off to them and let them tear it down when they're done. Second rule, don't forget to pause when keying up the link. In fact, on the IRLP website, it says the first 3 rules of using IRLP are pause, pause, and pause, right? You want to give time for all the systems on the other end to activate, especially if you're connected to a reflector or EchoLink conference or something like that. You don't want to just key up and start talking, because if you do that, the first few words that you say won't be heard by anybody but you. Don't hog it. Keep your usage short. There are, however, scheduled nets and RAG-true reflectors and conferences that will be out there and available. Good idea to check with the repeater owner first if you're going to do that. Obviously, with EchoLink, if you're an EchoLink user, there's no repeater involved. So if you connect into one of those RAG-true type conferences, it's fine to just chat all day long. But in general, keep your usage short. Other people might want to be using that particular connection. Remember that emergency traffic trumps your QSO about how the weather is in Zimbabwe or wherever you're talking to, right? So if somebody comes on the repeater and says, hey, I've got an emergency, and you're in the middle of an IRLP QSO, you say, hey, IRLP user, we got to go. Somebody needs a repeater here for an emergency. 73, close down the IRLP connection and hand it off to them as quickly as you can. And
Jan,
yes, Neil, go ahead.
so can there only be one node opened at a time on, I guess, the repeater?
So every given IRLP node can only make one connection at a time. That's why they had
Okay.
to develop these reflectors. So if I have a connection from my node to that node in Price can't talk to any other nodes because it's talking to
Okay.
me, right? That's why the reflectors are used, where I can tell my node to connect into the reflector, and then somebody else can connect into the reflector. Someone, a third person can connect into a reflector, and we can all talk together. But yeah, in general, it's one connection, one message stream, right?
Right.
The last one.
Thanks.
Yep. The last one is avoid local comms when connected to a distant machine. As I say here, the people in Peoria don't care what the traffic is like on I-15 today. So if I brought up my IRLP connection to Peoria and I'm sitting there with that connection open, I don't want to have a conversation with somebody else here about the accident that I just saw on I-15, or the fact that somebody didn't make their exit or whatever. I don't need to have a local conversation with that link up to some other place. So that's just standard internet linking etiquette. Don't hog up that link. It's a limited resource, right? Listen first. Listen for at least 15 seconds before you start using it, because again, that pausing thing is a factor, right? Somebody might be there, they just haven't talked in a little bit. So you want to listen for a little bit before you start doing anything. Wait at least 5 seconds between transmissions. Again, as I mentioned before, to allow others who are on simplex links the ability to disconnect. They can't transmit if they're receiving. So on a simplex node, they can't send a command to that simplex node unless nobody's talking. So you need to allow a little bit of time between your transmissions to give people a chance to connect in and say, D73, I'm out, right? Don't forget to identify every 10 minutes. That should be standard practices for everybody. You should know that. Remember, when allowing third-party use of your radio and talking to international stations, there may be restrictive third-party regulations specific to the country you're calling. Some countries don't allow third-party traffic. Some countries allow third-party traffic, but only in specific cases or specific instances. You need to be aware of that. A lot of us technician class people who only ever talk on VHF and UHF never think about that, because we're not talking to other countries typically. IRLP and EchoLink let us talk to people all over the world. We need to be aware of those restrictions and limitations. Don't plan or start a net on a reflector or conference server without the owner's knowledge and permission. That kind of goes without saying. You don't want to hog up their system if they don't know that you're going to do it, right? Same thing applies with like the Intermountain Intertie. They say don't do nets on the Intertie. Now there are specific exceptions to that rule, but those exceptions are defined and known to the owners and operators of those systems. Do participate in nets and direct communication with other hams. Get out there, use that thing, talk to people, have a lot of fun. That's what it's for, right? We engage in this hobby not just because it lets us perform service, but we engage in it because it's fun. It's cool to talk to people on the other side of the planet. Even if you don't, you're not a general class operator, you don't have an HF radio. With IRLP or EchoLink, I can talk to somebody in Scotland or New Zealand or Australia or Africa or Japan or wherever, right? And I have done so. I've done that before, and it's really cool to be able to do that with your handheld radio that you paid, $35 for. So it's totally cool. Get out there and use it, play around with it, and have fun with it. All right. Opening up for questions, comments, and things of that sort.
I learned a lot. Thank you very much.
How are we on time? We're good. We're good on time. Okay. Questions?
Jan?
Yeah.
Would you say something about the problem of getting through a router? What does that entail? What is the problem?
Yeah. So EchoLink has this problem specifically, and I'll kind of go over it a little bit. Let me actually stop sharing this and go back to my browser, and I will pull up some stuff here so you can see what I'm talking about. Okay, so one thing I wanted to show you while I'm thinking about it, UARC actually runs an EchoLink node, an IRLP node down on what is it? It's a 76 node down on, what's the name of that mountain down there on the west side of Utah Lake?
North Mountain?
Lake Mountain. So they actually run a node, but if you're not a member of UARC, they don't tell you what the code, there's a special 3-digit access code you need to be able to use it. So for us, Marty is happy to let everybody use his IRLP node on the Butterfield Peak repeater. So feel free to use that. But if you are a member of UARC and you know that code, you can utilize that 76 node for that. Okay, so what was I going to show you? Let me see. We were talking about the router issue. So I'm going to bring up EchoLink. And we're going to go in here. And I'll tell you, EchoLink has amazing documentation. It's really, really, really good. They basically cover everything that you would possibly need to know. So let's talk about problem connecting to other stations. And this is kind of what you're talking about there, Vern. So you've got yourself set up, you're all hooked up, you can see the stations, but when you try to connect, you can't connect. There could be firewall in the way, there could be all kinds of stuff going on. Sometimes a station connects to me, but then they disappear. They might have a firewall issue. Another issue that comes up, and let me see if I can find that link. So they actually have this link to a firewall solutions page, and they have this set up so that you can confirm that you are able to get through your firewall or your router. And they tell you specifically, you have to allow UDP connections on port 5198 and 5199 to go in and out from your computer out to the internet and come in from the internet to your computer. And then you have to allow TCP outbound to port 5200. That 5200 is where the server is listening. Okay. So normally your router will be set up to allow any outbound connection. So this will just work. And normally your router will be set up to allow the system called UPnP, which the EchoLink software will use to inform your router, hey, I'm listening on 5198, 5199. If anything comes in for those, hand it to me. Sometimes your router doesn't do that. My router, for example, I run a software on my router called DDWRT, and it has some bugs in that UPnP area. So that's something that causes some grief sometimes. Let's actually look at this link. So there's this link here to portforward.com. And if you go there, this page actually has information on how to open up ports on your router for all these different kinds of routers. So if you've got a, let's find one that is unusual. Say you've got a, let's see if they have TP-Link on here. So you got a TP-Link router. You can go in here. Don't buy this software. It actually tells you, well, this page isn't telling me anything useful. These are supposed to tell you exactly how to how to actually make that connection. I take it back. This page is not as useful as I hoped it was. Never mind. Let's get out of here. Let's go back to this. Basically, you need to access your router configuration. I'll show you how to do it, how I did it on my router. So my router is 192.168.1.1. And this is my DDWRT software on my router. And if I go into NAT, you can see here I have port forwarding set up. I actually set up range forwarding for EchoLink, port 5198 through 5199, UDP routes to this is my laptop's IP address. Because I set this up, if I was going to try to run EchoLink on a different computer here at home, it wouldn't work because I hard coded this. Normally, it's going to use this system called UPnP. And if you see here, you can see that UPnP is already forwarding a couple of ports here at my house, Torito and something on 9308. Torito is something that's used by Roku, and the Hulu system uses that. I don't know what 9308 is, but it looks like 216. I'm not sure what that IP is, which device that is, but that might be my my DMR MMDVM system. I'm not sure, but basically, normally it will use this UPnP system. You won't have to actually do anything special. It'll just work. If it doesn't just work, you'll have to go into your router and set up some kind of port forwarding like I did here. For whatever reason, the Echo Ham software doesn't do it quite correctly. And I did poke around with it. I traced the network connection. I decoded the packets going back and forth, and I couldn't see it ever actually making the request to open those ports. I could see it finding my router, but it never actually made the request. So that was unfortunate, but it's what it is. So I had to hard code those into my router. Hopefully you won't need to do that. If you're not using Echo Ham, if you're on a PC or something, your PC should automatically bring those port forwards up using UPnP, and it should just work. Let me go ahead and stop that again. Let's see. Chris says that Windows updates can mess up EchoLink. If that happens, uninstall it and reload it, and it works again. So that's good to know. All right. Let's go back to this page. So other questions?
This is Dave. I got the couple comments.
Go ahead.
First, with the EchoLink, there are some EchoLink nets that do both voice and also chat room check-ins, and they have somebody read the text message check-ins. The other thing with some of these digital modes are interconnected, and to when you push the PTT or transmit, wait a few seconds so they can all link together. That's what I have. Thanks.
Yeah, thanks, Dave. Yeah, so we did mention that as part of the etiquette here. Don't forget to pause when keying up the link. Make sure you give time for all those systems to activate. But it's good to say that again, just to make sure that that's in people's thoughts and in their process when they're thinking about this. Pausing is good. Key up, wait a few seconds before you say anything. Same thing applies on the intertie or any other linked system. Every now and then you'll hear somebody on one of those systems where they, you'll hear like this rapid fire back and forth between two stations, and you're sitting there thinking, wow, if those guys were on a link system, nobody would hear anything because they're going back and forth so fast that the system wouldn't have time to keep up with them. Chris, go ahead. You had a comment.
Yeah, another one that you might want to look into is Peanut. I don't know if you have that one.
I have never heard of that. What is
Peanut?
all about?
It's written by a guy named Dave from the Netherlands, and it's free. Again, you have to verify that you are a certified ham radio operator, but it is a fully digital mode, and it has connections into System Fusion, D-Star, and several others. Plus, it has their own rooms as well. But that's just another one, very much like EchoLink and these other ones. So just something else that if you're interested in doing these kinds of things, you just download the software onto your computer, set it up, and join a bunch of chat rooms.
And away you go, right? Yeah, there are interconnections sometimes between DMR talk groups and EchoLink conferences and IRLP things as well. I've seen systems that connect those together. So that is a thing that is done on occasion. Vern, go ahead. You had your hand up.
So I checked in on the Utah DMR net last night, and there's a significant lag between conversations, and that's the same thing you're talking about. Is some people are actually over RF, and others are going through the internet, and they have to wait for everything to connect. Is that correct?
Yes, you definitely have that as an issue, right? Because if you think about it, when you're on like that DMR connection, right? It uses that what is it?
Bridgecom,
right? So when you key up your radio, your repeater, Brandmeister, that's the one.
Yeah,
that's the one. Brandmeister. When you key up your radio, it has to communicate to that kind of central server and say, "Hey, I'm bringing up a connection. Here's my data stream," and then that is going to actually send that out to everybody who's on that same talk group, right? So whatever repeater they happen to be on, those are all kind of interconnected out on the internet, and so you have to wait, give it a second or two to allow all of that to happen and all those radios all the way around to come up and start handling that. And the same thing applies with DMR when you're talking on a non-local talk group. Now, if you're on a local talk group, it's just your repeater between you and your repeater and other people who are listening to your specific repeater. But if you're on any of the local, regional, or global talk groups, then yeah, you do have that as an issue. That actually happens on commercial systems as well, like the P25 systems and such, where those systems have multiple radios and they have like a control channel that when you key up your radio on a particular talk group, when you key up your radio on a particular talk group, it basically says, "Hey, assign me a frequency pair for my transmission here." And so you could actually key your radio up and not be able to start talking for a second or two if there aren't any available audio channels on those public service type systems, like UCAN or whatever. And so, we run into that same kind of thing when we work with digital modes, and the same kind of thing happens with any kind of linked system, right? If I'm here and I key up the intertie node on Farnsworth, I have to wait for all the repeaters from West Yellowstone all the way down to Vegas to come up and be ready. And that takes a little bit of time. So usually you wait a second, or you key up, you wait a second or two, then you start talking. And it does feel a little bit laggy sometimes, but that's just the nature of that type of wide area operation. So all good information. Other questions, comments, things of that sort? Chris has posted a link to Peanut. I will put that on the website as well. Thanks, Chris.
He's got a number of other novel software for Androids and iPhones and tablets and PCs. DudeStar, DroidStar, these are all emulators so that you can actually talk on D-Star without having a D-Star radio and those sorts of things. The guy's, and it's all free. The guy does a great job. So I do recommend, if you do download some of his software, a $5 donation to help fund his website and everything else sure would be nice. But it's good stuff. Check it out.
Buy him a cup of coffee or a pizza or something.
Yep, buy him a pizza. That'd be dynamite.
All right. Other questions, comments? Hearing none.
I'm personally waiting for the almonds version.
As opposed to peanuts? Are you
As
allergic to
opposed
peanuts?
to peanuts, yeah.
I mean, what if you're allergic to peanuts? You might.
No, cashews. They're going to have it. He's coming out with a cashew version.
You're more likely to be allergic to tree nuts than peanuts, I think. So, all right, I'm going to go ahead and stop the recording and.